Good morning and welcome to the OBX Wave Report for December the 14th, 2022. I am your wave reporter, your climate and extreme weather, and your beach lifestyle reporter, Robert Scribbler. And before I start today's video, I want to ask a little bit of a rhetorical question. Where is the best place on the East Coast and one of the best places in the world to observe the impacts of human-caused climate change and related extreme weather? Oh, actually, let's see. Where is the second best place to observe these impacts? And in my opinion, the second best place to observe these impacts is right here on the Outer Banks on this thin strand of basically overgrown sandbars that run from southeastern Virginia, starting in Sandbridge, and then all the way down to Wilmington, North Carolina, that juts right out into a rapidly changing, rising, and increasingly more stormy Atlantic Ocean. Where is the number one best place to observe these changes? Well, in my opinion, it's on a surfboard or a bodyboard right out there in the changing Atlantic Ocean. And I know it sounds crazy, but that's what we're gonna do. We're gonna we're gonna do that thing. We're building up to it, and for those of you who have come along for the ride are certainly in for some rides with me. Now, for today, for this OBX wave report, we are going to step back. We have had one big storm in the central Atlantic, and I mean, for recent years, this big storm that we just experienced, this huge wave maker that pumped out 45-foot significant wave heights in the central Atlantic and just pumped out a huge swell that turned the Atlantic Ocean into a big old giant wave bathtub. That thing at around 950 millibars was strong. It was a strong storm system. Something 950 is in the range of, if you compare it to a tropical system, some of the stronger hurricanes, maybe a Category 3-ish, strong Category 3. But some of the storms that we've seen in the North Atlantic recently during wintertime have been considerably more intense. And recently, well, not recently, I'd say about 7 years ago, I tracked a major storm system that formed off the coast of Greenland that hurled tropical air all the way up to the North Pole and warmed the North Pole up above freezing during late December, just after Christmas time. And that, among weather observers and climate observers, that had hitherto been either an extraordinarily rare event or an unheard of event. And it became one of the many indicators, one of the many data points on a long list of indicators showing how the Earth system is changing as it warms due to fossil fuel burning and the injection of carbon into the Earth's atmosphere. So, storms in the North Atlantic and the movement of air masses in the North Atlantic and in the polar zones and around the world are impacted by this warming of the Earth, which does not occur evenly. It is, uneven for land masses, is uneven for ocean masses, and when you get that unevenness, you can get the potential for more storms. And in addition to all of that uneven warming, you also have warmer overall lands and warmer overall oceans that are evaporating more moisture into the air at a higher rate, which provides another trigger for storms in the form of convection. Now, there is some argument among scientists, and rightly so, about whether or not there are mitigating factors for these observed increased potentials for storms in the form of, convective energy from evaporation and unevenness and variance in temperature. And I'm not going to go into the counter arguments. My area here, as a weather observer and as a surfer, is to track storms and to learn about the nature of storms, both for my surfing and just for my lifestyle here at a beach, which is vulnerable to storms in general. So for today, what we are going to do for the wave report is we are going to tell a bigger story. We focused on the storm, we focused on some waves, but for today, we're going to look at the larger weather conditions for the Northern Hemisphere at present. And we're going to ask the question, how stormy is the 2022 and 2023 winter going to be for the North Atlantic? And we're going to look at a number of factors. We're not going to be able to tell you the answer entirely, but what we can do is tell you what the long range forecasts are from the National Weather Service and from NOAA. We can tell you some of the synoptic conditions and prevailing conditions in the form of large global weather influencers such as the El Nino and La Nina cycle. And we can observe what the ocean surface and jet stream are doing now. Um, Warmer ocean surfaces provide more fuel for storms. Wavy jet streams, in some cases, can provide more fuel for storms. Stronger storm tracks over various zones can also provide more fuel for storms. So we're going to look at those. We're also going to look at variance in temperature from like in regions of the globe in the northern hemisphere. So all these things can influence storms, and so we're going to look at that and think about how stormy is the North Atlantic going to be this winter. And again, I am a a weather observer and reporter on these issues. If you want to delve more deeply into the official references or talk directly to a professional meteorologist or climate scientist, please do. I am not going to make predictions myself because that is really not my job. I'm going to talk about the official predictions and I'm going to talk about the underlying conditions. So, and see if maybe we can tease out what might be coming for this winter. So, so a little nuance here, which hopefully that's okay. So in any case, looking at the NASA Worldview satellite shot, we have a march of storms across the US and the North Atlantic. You can tell that in these two swirls. There's a large storm system in the central US and another large storm system off of Newfoundland. These are marching from west to east and carrying with them their various weather conditions. Here in the Outer Banks, we've got a bit of a lull. The winds are calm. The air has, the clouds have cleared up. And so we're getting sunny and crisp conditions. And but we are waiting for the next storm system to run through. And I'm just going to show you the larger infrared satellite as these storms march across the US and out here in the North Atlantic. And over here off the Pacific, we've got the next storm system starting to form with these very large, very high cloud tops. The most recent storm system that hit the US West and Northwest dumped a huge amount of snow out there and is setting its sights now on the US East Coast as a number of thunderstorms begin to fire up and down this frontal boundary with warm temperatures in front of it and cool temperatures in the rear. So watch out for extreme weather, some extreme weather conditions in the U.S. Southeast, which means thunderstorm activity. May want to check out your local and regional weather forecast to see what your thunderstorm risk is for today, because some of these look pretty powerful. So something to look at here. Seems like a lot of instability in that region. But for the Outer Banks, over the coming days, we're going to see this front swoop in, and we're likely to see some thunderstorms, particularly on the more southerly facing areas of the Outer Banks. Um, that's the setting for this wave report. I'm going to go to the local level and talk about waves for today, and then we're going to get back to the larger weather conditions to try and tease out what the North Atlantic is going to look like as far as storms. So for today, December 14th, 2022 at Jeanette's Pier, the local Jeanette's Pier, which is kind of a science and fishing pier, which I just can't get over how cool that is. Wave heights are down a little bit from yesterday. They are in the range of 5 to 7 feet, still rather large. The wave period for the primary swell is 14 seconds and 11 seconds for the secondary swell. Winds are coming out of the west-northwest at 13 miles per hour, so a lot more gentle, and this is an offshore wave, which will tend to clean up the waves a bit. So it does appear that surf conditions are becoming a bit more favorable for Jeanette's Pier, even though the wave heights are coming down. You're likely looking at much cleaner conditions. The air temperature at Jeanette's Pier is a cold, I would say cold, 43 degrees Fahrenheit, and the ocean water temperature is 58. So do you have your cold weather protection available if you decide to go out and surf those 5 to 7 foot waves over at Jeanette's? The weather conditions are partly cloudy with an expected high today of 48, so not getting too much warmer today. Moving on south down to Avon, we find that, let me get here on the satellite map, going past Rodanth, beginning to turn toward Hatteras Island down Route 12. So at Avon, just north of Hatteras, the wave conditions are 4 to 6 feet with a primary swell of 14 seconds and a secondary swell of 11 seconds. Winds are also out of the west-northwest at 14 miles per hour with the slight southeast cant to the beach. This is coming almost directly offshore. Air temperatures are 46 degrees Fahrenheit and ocean water temperatures are 65 degrees Fahrenheit. The weather conditions for today, according to the National Weather Service, are expected to be partly cloudy with a high of 52 degrees with possible slightly warmer conditions down right at the beach there. And then moving down to Buxton, where we observed some just raging surf yesterday. Beautiful black beasts getting spewed up out of a stormy Atlantic in the range of 12 to 16 feet. I don't know. I think there might be something about Buxton. It's this wave location has consistently produced very large waves throughout this storm event. So it may be that the bottom is deeper, the way the swells form, or there might be just more of an ocean influence here. In any case, it's just big. Buxton is big and kind of scary. It's intimidating. It's got teeth. It's a bit of a beast. So right now, again, waves at Buxton are larger than throughout the Outer Banks. The wave heights are right now between 9 and 10 feet, which is certainly nothing to shake a stick at. A primary swell dominates with a period of 14 seconds. Winds are out of the northwest, so canting a bit more to the north at 11 miles per hour, which is a pretty gentle flow. This will also tend to clean up the surf there if you want to brave those beasts over there at Buxton. The air temperature is 45 degrees Fahrenheit, and the ocean water temperature at Buxton, which to me seems to indicate a bit more of an ocean influence here, is 70 degrees Fahrenheit. Seems like maybe a little tongue of the Gulf Stream is getting in there and warming up the sea surface temperatures. Weather conditions at Buxton are partly cloudy with an expected high today of 52 degrees Fahrenheit. And last of all, typically we do 3 to 4 observations. I've been leaning toward 4 recently because it just seems to be a good way to get a character of the OBX surf. So heading down to Billy Mitchell Airport, which is a historic location here on the Outer Banks. Wave heights in the official monitor right now are between 2 to 3 feet, with the primary swell coming in at 14 seconds and the secondary swell coming in at 10 seconds. It's worth noting that the swell indicator for the primary swell is measuring 5 feet. So it might be that Billy Mitchell's official swell is undershooting the sets a bit, so sets might be a bit larger. But generally speaking, the south-facing beach here is calmer and the waves are smaller, which is what we would expect because most of the storms are pushing in those winds out of the northeast, and so the swell, the fetch that we're getting is a northeast swell, and the swell that we're getting down here on the south-facing beaches is a more of a wraparound, so smaller wave conditions there, although maybe not as small as indicated. Winds are out of the northwest at 10 miles per hour, so coming in here out of the northwest would be like about here. So this is offshore flow as well. And then the air temperature at Billy Mitchell right now is 45 degrees Fahrenheit with an ocean water temperature of 67 degrees Fahrenheit. Worth noting that ocean water temperatures here on a slightly more southerly beach are cooler than those indicated up at Buxton. So Buxton, again, seems to have a bit more of the Gulf Stream influence. The weather conditions at Billy Mitchell right now are partly cloudy with an expected high of 52 degrees Fahrenheit. So that's a rundown of the local weather and wave conditions for 4 select locations on the Outer Banks as part of our wave report for today. So now let's zoom back. Let's pull back and take a look at the larger weather conditions for the Atlantic region and then the influencing weather and climate patterns for the Northern Hemisphere. So starting off, we're going to look at waves across the North Atlantic. And the North Atlantic is still pretty much, a big wave spot right now. Big waves from, my context. So the Outer Banks right now, just offshore, are experiencing 7 to 8 foot. Oh, I'm sorry, it looks like 6 to 8 foot significant wave heights for the region. So still very large, significant wave heights for the offshore swells. The near offshore environment of Florida, the central coast of Florida has experienced 6 to 7 foot wave heights. The Bahamas are experiencing 7 to 8 foot wave heights just offshore. And the north-facing beaches of the Caribbean are experiencing 6 to 7 foot wave heights right now as well. On the European side, just off Portugal, wave heights are in the range of 16, maybe pushing up to 17 feet. And then just offshore for, looks like Ireland, we're experiencing 13 to 14 foot wave heights. And then northern England has just this crazy fetch running off the extreme North Atlantic here in the range of 16 to 18 feet, which is just nuts if you ask me. I don't know who might be surfing these big waves here in northern England, but if anyone's brave enough to get in that super cold water with a dry suit and go out and deal with those gnarly, huge waves coming out from the Arctic, basically, spat out of the Arctic at you. More power to you. You're pretty much, yeah, tough guy in my book. All right, so looking at our, I wanted to, so that's some context for present wave conditions in the Atlantic Ocean. Now, pulling back even more, I just want to show you the march of low pressure systems around the pole here. Um, so in wintertime, particularly, you get this parade of low pressure systems circling the northern hemisphere around the cold core in the Arctic. And you can see just this chain of lows just circling around these storms, one after another doing their dance around this central point. And here is our offshore low here at 972 millibars, and then the large low pressure system in the central US, which has caused so much storminess on the west and is right now triggering some storms for the US Southeast, and another developing low pressure system just off the west coast. And this is what you expect during wintertime, this chain of lows just swirling about in the middle latitudes, making things relatively stormy for the northern hemisphere winter as they just march across the middle latitudes. And so that's a good starting point for our discussion. I wanted to also take a look at global temperatures, or actually northern hemisphere temperatures, to look at temperature variance. And right now, of course, as we would expect, the Arctic is cold at minus 19 degrees Fahrenheit, right there near the North Pole. So very cold up there. But it's worth noting that the coldest conditions are in Siberia, over on the continent, with temperatures ranging as low as nearly negative 60 degrees Fahrenheit, which is really cold. The Arctic has an ocean influence, and as the sea ice has thinned, the temperatures for wintertime have increased considerably. And what we have tended to see is that the continental cold is greatly amplified. And then over here on Greenland, we have minus 52 degree Fahrenheit conditions on the top of the ice sheet up there in Greenland. So those cold conditions do juxtapose much warmer conditions over the ocean environment. So if you get down into the ocean, that's, looks like maybe about 1,000 miles away, and that's not really a huge range for, like this variance. You have 50 degree or 48 degree conditions. So you basically have a 100 degree Fahrenheit range of variance between the continental cold over here in Siberia and the oceanic warmth here in the Pacific, which is pretty wild. If you pick even two closer locations, you can go south of the Aleutians here and get a 43 degree Fahrenheit ocean condition. And then just to the north here in Alaska, the temperature is negative 15. So you have about a 60 degree variance in temperature over the course of 300 to 400 miles, which is, pretty tight variance. And then here in Greenland, just off, you got that negative 50 degree temperatures in central Greenland. And then in the North Atlantic, you've got 42 degree Fahrenheit conditions, which is a 90 degree variance over the course of maybe about, 400 to 500 miles. So you've got some tightly packed warm to cold conditions. I'm just going to do one more here. So for the Southeast Canada, you got 16 degree Fahrenheit, and then out here in the Gulf Stream, you've got 60, which is, doing some math here, about 44 degree variance of temperature in a relatively tight zone here. Now, these variances, differences in temperature do provide fuel for storms. If you've got tightly packed thermoclines, you can get more fuel for storms generally. And that's basically what we're looking at as one of the primary factors for storm fuel. You got some tightly packed thermoclines. So, we got tightly packed thermoclines, but what we've also got as well is a pretty wavy jet stream. In this cold zone here in Siberia, we've got a deep dip in the jet stream that is pulling that cold air down from the Arctic. Across the Pacific, we've got what appears to be a pretty intense jet stream that then gets turned into this big wavy pattern here in the central Pacific. And this is likely due to much warmer than normal conditions here in the central Pacific. I'm going to talk about that in a minute. As the jet stream gets pushed up here into Alaska, taps into that cold air, and then dumps back down into that very warm Pacific, which lately has been helping to generate some strong storms. Now, um, oftentimes, like traditional meteorology tends to lean toward a stronger jet stream running across the Pacific, creating powerful storms. So that's something that is worth noting. And right now we have more of a meandering jet stream, so that might be a little bit of a countervailing influence for storms. And then the jet stream also goes through this whirly gig of loops and dips over the US with some upper level lows here. And then we get some ridges and troughs also in the jet stream running across the Atlantic. So the jet stream is very wavy right now in early December, not a very flat jet stream. And so and that will also tend to fuel that variance in temperature, which can be a trigger for storm development, um, but we're not seeing a raging storm track across the Pacific. So possibly two countervailing influences here. I know we're getting into nuance, but it's that's kind of what you do when you're looking at storm influence. Now, I did talk about this very warm Pacific Ocean, and the warm Pacific is much warmer than normal here at 8 degrees Fahrenheit. So you got a big blob of much warmer than normal conditions all throughout the north central Pacific. And this blob is out there evaporating a lot of moisture in the atmosphere, and it's also creating that gradient between hot and cold there. So those influences would tend to favor storm development, having all that extra convection there in the north central Pacific and increasing the gradient between, well, in this case, east and west, as well as north and south. It's worth noting that the equatorial Pacific is cool, so we're still in La Nina conditions, and we get a synoptic La Nina environment here. We're going to talk a little bit about that. The Gulf of Mexico is also much warmer than normal, about uh, looks like 3 to 6 degrees Fahrenheit above normal. So that extra heat and moisture is going to be a trigger for storms in the southern and central US and the Great Plains, something to look at for severe storm development and and possible severe thunderstorms as frontal systems swoop in across the Rockies. So we've got more fuel here in the Gulf of Mexico to fuel those storms. And then off the East Coast, we've got warmer than normal conditions in the range of 2 to 8 degrees Fahrenheit above normal as well. And I'm going to zoom in a little bit more to get some of the hot spots here in the Gulf Stream are just crazy, as well as in the Labrador Current up here. So you've got 18 degree Fahrenheit above normal ocean surface temperatures and little spots and little hot spots. And this just off the US Northeast coast, as well as up here. Yeah, so 16 degrees Fahrenheit above normal in some hot spots, and ranging between about 3 and 18 degrees Fahrenheit above normal up here in the near ocean environment for the US Northeast, as well as still rather warmer than normal conditions for the larger oceanic zone just to the east in the range of 1 to 2.5 degrees Fahrenheit above normal. And again, these ocean surfaces will evaporate more moisture and also help to create that gradient, and will also help to create that gradient, which helps to fuel storms. So this is something that we want to pay attention to here on the Outer Banks and across the US, because this bad boy here, if you get cold air slamming into it, you can get all sorts of instabilities and lows that tend to develop. So something to keep an eye on, particularly from a convection standpoint as well as from a gradient standpoint. And then last of all, I just wanted to show the sea surface temperatures in a real sense, just to also show you what's helping to fuel that gradient. So out here in the Gulf Stream, we've got 62-degree Fahrenheit water just off the Virginia coastline, and then air temperatures above the continent are going to be much colder than that, particularly as the fronts swoop down. So also another aspect that helps to fuel that gradient for storms. And worth noting here, like at the end of the Gulf Stream, as the Labrador current converges, sea surface temperatures are a range of 64 degrees Fahrenheit, and then in the Labrador current, you've got much colder water temperatures in the range of 33 degrees Fahrenheit. So also a very tight gradient there. That's a like a traditional gradient. The Gulf Stream and the Labrador current confluence has always had that variance, but it's just worth noting as a trigger for potential storm formation. In the North Pacific, there's warmer than normal waters in the range of 61 degrees Fahrenheit, with water temperatures near the Aleutians in the range of 42, and out here in the Bering Sea at 32. So also quite a bit of variance across this Pacific Ocean zone. So right now we've been looking at variance in temperature. We've been looking at the jet stream, which is helping to fuel those temperature gradients, both at the ocean and at the land level on the surface. And we've been looking at storm tracks, which in some cases, due to the wavy jet stream, may not be as intense, but you might have some countervailing influences here because cold has been placed very close to warm, and you've got increased evaporation off the land and ocean surface. So a nuanced view of conditions that contribute to storm formation across the northern hemisphere. Um, Now I want to talk a little bit about El Nino, and La Nina. So right now the Pacific is in a long-running La Nina event that began in 2020, and we've had the equatorial waters in the Pacific range in the La Nina zone for most months over the past 3 years. And this La Nina influence is something that we pay attention to during summertime because it helps to, or tends to help to reduce wind shear in the North Atlantic, which can increase the potential for hurricane formation during the summertime. But during the wintertime, it also has an impact on US weather, one that may be a little bit more subtle, but is worth taking note of. And so what I'm going to do is point you directly to the larger forecast provided by NOAA for the United States. Well, the larger observations provided by NOAA for the United States with regards to precipitation and temperature. So for precipitation, the US Northwest and Central US has been drier than normal over the last 30 days. And the Northeast and Southern United States has been wetter than normal. And for temperatures, the Northern US and the Northwest US has been rather colder than normal, whereas the Eastern US and Southeast particularly has been warmer than normal. And so again, you've got a little bit of that gradient setting up. So you might have some strong central US storms. And looking at the outlook for the next few months, what we expect based on the synoptic weather patterns and the present state of La Nina in the Central Pacific is above normal precipitation for most of the northern tier of the US, dipping down a bit more into the Ohio River Valley, so above normal precipitation potential. And when you have above normal precipitation potential, that's just an indicator that that's where they expect more storms to form and dump more weather. And then for the southern US, they expect below the weather experts expect below normal precipitation, which might be an indicator of less stormy conditions. Here on the Outer Banks, we're leaning toward below normal in the synoptic forecasts and the longer term forecasts. So it might be a little bit less stormy than normal generally, but that does not necessarily have a as much of a you know produce as much of a factor for individual storms. Individual storms might fire off stronger. And again, we've got some climate factors in the mix that may or may not be taken into account or as much into account into these models. The models are getting better, and they're always getting better. But it's just worth putting a little asterisk there on the climate influences, which may create a little bit more of an unexpected variance, a kind of new normal kind of variance. And then the seasonal temperature outlook for the Northwest is for below normal temperatures, and for a larger region of above normal temperatures in the US South, particularly in the Southeast, and then for the US Northeast. So a longer term weather forecast indicating stormy conditions for the northern US for the most part, and warmer than normal and drier than normal conditions for the southern US, according to NOAA. So a broad look at some influences that may affect storm conditions here in the Outer Banks and in the North Atlantic. Generally speaking, I expect to see some powerful storms out there given how warm those ocean waters are. And even though we on the Outer Banks here might not be as likely to expect consistent stormy conditions as we would during a normal year, the warmer than normal sea surface temperatures and the high variance between hot and cold, for me, does provide a little bit of a higher alert state because I want to be alert to storms that have more fuel and what happens to them when they form. I'm going to be out there looking at the waves, looking at the ocean, and providing these reports to you. So this gives us a larger view of the broader skein based on weather history and what's going on in the climate. Just one final point before I end. Here on the Outer Banks during wintertime, the average wave heights are in the range of 7 feet. So the ocean out there is traditionally very stormy right here off the Outer Banks during winter, and in the North Atlantic also gets pretty radical and produces some big waves for this region. So that's one more little point of context as we talk about how stormy the North Atlantic will be for the winter of 2022 and 2023, and how large the waves and how radical the surf conditions will be. So thank you for joining me for another episode of the OBX Wave Report. And please remember to do everything you can to help save our beautiful shores from the impacts of climate change driven by fossil fuel burning.